Hello everyone. Today I'm going to talk about data pipeline architecture, ETL, ELT, and ELTL. My name's Hoa. I'm a data engineer with 2 years experience in data engineering. About the contents, in this talk, I will not talk about any specific projects. I just focus on answering a big question. Why do we need a data platform? And I also share typical data pipeline architecture. You may hear a lot the word ETL. So, what does it mean? And what are its variations? At the same time, you can see some sample data pipelines that I show in my presentation. But first of all, we need to talk about data sources. Actually, there are so many data sources that your company may have. Data may come from OLTP system. Online transactional processing system, which support for operational application. And the data can be stored in RDBMS, relational database management system, or some kinds of NoSQL database. Data also may come from social media platform, and you may also you may collect user activities and user behaviors data. I think every company have a data related to system or backend logs. And if you work in an IoT company, data also come from sensor devices. So there are a lot of data sources that may be distributed in your company, and how we how can we leverage how we can leverage and take advantages of our existing data in our company. I think we should build a data platform, but basically, you know the data platform may have many things like data catalog and metadata management, data discovery and observability, data quality and data governance, data documentation, and data lineage. But basically, we should focus on at least three elements, including data lake, data warehouse, and data pipeline. So, why do we need the data pipeline? And do we really need the data lake or the data warehouse? Absolutely yes, because the data warehouse or data lake can be a centralized data platform. As I mentioned before, the data sources are distributed in different places. It will be great if we can centralize the data in a place where the data analyst or data scientist can query the data. Secondly, differences in the data modeling between data sources and data destinations. Normally, in the OLTB system, the data is normalized like the big a big table can be divided into many smaller ones. But in the data warehouse, we may need the dimensional model or flattened model with big table containing a lot of columns. And at that time, we may need to join and combine data together again. About the format, because the data platform will support for the data analytic projects that will query a lot of aggregation queries, and the data format in the data lake or the data warehouse should be in the columnar format. So it will give you a good performance when you do the aggregation queries like some average in some columns. And in your data platform, you can store historical data because in some operational application, we may need to archive the old data to have a better performance and save the cost as well. But in especially the data like we can store all our historical data. So because of the different purposes between the operational application and the data platform. The data warehouse and data lake can support the data analytics and data science. So we should build a historical data platform. And you know, we have the data sources. We have the data destinations, which are the data lake and the data warehouse. So between them, we need to build the data pipeline to ingest data from the data sources, applied some transformation to and load it to our destination. So we have the ETL acronym. It stands for extract, transform, and load. In this picture, we have the transformation step, and the transformation in ETL reflects the business logic and model. And what will we do in the transformation step? I would say, in this step, we will validate, clear the data, or join the data together. And finally, we will load the clean data to our destinations. Next, a, a variation of the ETL is ELT. You know, in ELT, first we will extract data, but then we load raw data to our destinations. In the destinations, we will have the raw data in the data platform. You can see we load the raw data into data warehouse, but this area we name it as the staging area. From the staging area, which contains raw data, we will apply some transformation to raw data and then load it to other layers of the data warehouse. So I could say there are some benefits of having raw data in our data platform. In cases of data pipeline failure, we may need to reprocess the data or business logic change. We need to apply the new transformation to the old data. We will need to do the data reprocessing. At that time, we will look at the raw data and the raw data into data platform instead of connecting to data sources again. The raw data also serves for the data quality assurance perspective because your team can have a tester and the tester can look at the raw data and test the transformation that you already wrote based on the business logic. The raw data also serve for unseen purposes now. I mean, in the future, you may need to extract more features from the raw data that you do not see now. So I strongly recommend that we need to have the raw data in the data platform. Another variation of ETL is ELTL. You know, this is this is the this is the data pipeline in ZCB that you have some data sources here. First step is loading the raw data into our data lake. I mean cloud storage in ZCB, and then process the raw data to get clean data. And for the data processing, I'm using Apache Spark now that can install data the cloud data prop, which is supported by CCB. After this step, we have the curated or refined data load to other areas of cloud storage. From this refined or curated data, use Spark again to read the data from this area, join the data to generate or create a star schema, and load the data to BigQuery. In BigQuery, we can use SQL BigQuery to populate further layer like data mark. In BigQuery, we can use DBT or data build tool to write your transformation within the BigQuery. When having refined data in cloud storage, you can query the data by different tools like Apache Presto, which is supported in the cloud Databricks. For the data analytic purpose, you can query the data in the data warehouse, BigQuery, as well as refine data in the cloud storage. Scientists or analysts can take advantages of raw data and the refined data in the cloud storage by using Jupyter Notebook, which is supported by Vertex AI. You know, this picture is the page data highlight, which is scheduled by Apache Airflow, installed by Cloud Composer in GCP. Wrap up time. Building your own data pipelines. When building your own data pipeline, you should consider to build data lake, data warehouse, and data pipelines for your company. You know, I you should bear in mind ETL and ELT are not mutually exclusive of each other. Both can be considered as parts of a broader data integration strategy. And moreover, if you are currently designing data pipelines for data warehousing or a data lake, you may want to consider ELT or a hybrid approach. The hybrid model is typical with data lake workflows. I love discussing with you all about other data topics such as streaming data pipeline, Kappa, and Lambda architecture, data mesh, etc. in other questions if we have a chance. Thank you for your time and goodbye.